Xiaomi just announced something that should make every AI company in the world nervous. They've released MiMo-v2.5-Pro Ultra Speed, a trillion-parameter language model that processes text at 1,000 tokens per second. To put that in perspective, that's roughly the speed at which a human reads a sentence. Most state-of-the-art models run between 50 and 150 tokens per second. This model is 6 to 20 times faster, and it hasn't given up scale or capability to get there. Think of tokens like individual words or word fragments. Every time an AI generates a response, it's predicting the next token, the next chunk of text. The faster it can do that, the more responsive the experience feels. 1,000 tokens a second sounds like a number on a benchmark sheet, but in practice, it means instantaneous responses for real-world applications. Real-time translation that doesn't lag, code completion that keeps up with your typing, customer service chatbots that feel like they're actually thinking instead of buffering. This is the moment when AI speed stops being a constraint and becomes a competitive advantage. The question isn't whether this performance is possible anymore, it's why it took until now to get here, and who else is racing to match it. To understand why 1,000 tokens per second is a breakthrough, you need to know where we've been. 2 years ago, if you wanted a truly powerful language model, one with 1 trillion parameters, you were stuck waiting. 1 trillion parameters means 1 trillion little adjustable weights in a neural network. More parameters generally means better reasoning and knowledge, but bigger models are slower to run. You'd get your answer in 5, 10, sometimes 30 seconds. Companies made a deal with themselves, accuracy over speed, but the market started demanding both. Cloud AI services like OpenAI's GPT and Google's Gemini optimized for speed at scale. They built data center infrastructure that could split inference across multiple GPUs. That helped, but it's expensive and only works when you've got unlimited compute budget. Meanwhile, mobile manufacturers and device makers faced a different problem. They wanted intelligent features running directly on phones and laptops without shipping every query to the cloud. That's where Edge AI comes in, running models locally on device, but local hardware is constrained. A smartphone's GPU or neural accelerator is powerful, sure, but it's nowhere near a data center's GPU cluster, so Edge AI models stayed smaller. You'd get speed but lose capability. Xiaomi's MiMo-v2.5-Pro flips that equation. They've figured out how to run a 1 trillion parameter model so efficiently that it hits speeds previously only possible with models 1/10 the size. How do you make a 1 trillion parameter model run at 1,000 tokens per second? It's not magic, it's engineering at several different levels. First, hardware optimization. Xiaomi's pushing this on their own silicon. They've built custom AI accelerators, dedicated chips designed specifically to run their model. That's different from trying to squeeze the same model onto a generic GPU. These accelerators are shaped by the model's architecture. Every bit of computation is tailored to minimize memory reads and maximize throughput. Think of it like designing a highway system for one specific pattern of traffic, rather than trying to fit general-purpose roads everywhere. Second, model architecture. Not all 1 trillion parameter models are built the same way. Xiaomi's use techniques like quantization, storing weights in lower precision formats instead of full 32-bit floating point. You might store a weight in 8-bit format instead. That sounds like you're throwing away information, but with careful calibration, the model barely notices. You've just cut your memory requirement by 75% and made computation faster because you're moving less data around. Third, batching and prefilling. The model can prepare certain parts of the response before you've even finished typing your full prompt. It predicts likely continuations and precomputes token embeddings in the background. When you actually need the token, it's already halfway computed. And fourth, quantization-aware training. Instead of taking a model trained in full precision and then quantizing it, Xiaomi trained the model from the ground up knowing it would be quantized. The neural network learned to be robust to that constraint. All of these together create a model that delivers enterprise-grade reasoning speed on consumer hardware. Speed in benchmarks is one thing. Speed in actual applications is what people feel. Let's walk through a few scenarios. First, real-time translation. Imagine you're in a meeting with someone who speaks Mandarin and you speak English. Traditional cloud translation APIs add latency. You finish a sentence, wait for the server call, and then get your translation a second later. Awkward. With MiMo running locally on a smartphone at 1000 tokens per second. You hit the speaker button, talk for a sentence, and get a translated caption in real time, less than 300 milliseconds. No server trip, no privacy leakage of sensitive business conversations to the cloud. Second, coding assistance. Most developers use AI to autocomplete code. Copilot-style tools generate the next few lines of code while you're typing. If the model is slow, you're always waiting. You type a variable name, pause, and then the suggestion appears. With 1000 tokens per second, suggestions appear before you've even lifted your fingers from the keyboard. You're not fighting the tool anymore, you're in flow. Third, customer support chatbots. Call center AI needs to respond faster than a human. If the AI takes 5 seconds to formulate an answer, the customer perceives it as thinking slowly or frozen. At 1000 tokens per second, an average response of 100 tokens comes in a tenth of a second. The bot feels snappy and competent. Fourth, medical diagnostic assistance. A doctor uploads a patient's symptoms and scan images to an AI system. The faster the response, the faster the diagnosis process moves. Seconds matter in emergency settings. These aren't edge cases, they are mainstream use cases that only work when AI is fast. MiMo isn't operating in a vacuum. There are other trillion-parameter models out there, and there are plenty of teams racing to match this speed. Let's put it in context. OpenAI's GPT-4 has an estimated 1.7 trillion parameters, but it's primarily cloud-based. Latency from cloud APIs typically ranges from 1 to 5 seconds for full response. That's not a fair comparison though. GPT-4 is optimized for maximum accuracy and reasoning, not raw speed. But here's the thing, plenty of use cases don't need GPT-4's absolute peak reasoning ability. They need fast, good enough responses. Meta's Llama 3.1 405 billion parameter model can run locally, and it's fast, but it's not trillion parameters. You get speed at the cost of capability. Google's Gemini models are cloud-based, and while they are incredibly capable, they also have cloud latency. Anthropic's Claude is similar. What Xiaomi's done is different. They've taken a trillion-parameter scale model and optimized it ruthlessly for inference speed without gutting capability. The nearest competitor in terms of edge-optimized speed would be smaller models from companies like Mistral or local implementations of Llama. But scale matters for reasoning. A 405 billion parameter model will generally out-reason a 13 billion parameter model on complex tasks, even if both are fast. Xiaomi's claiming the sweet spot, trillion parameter reasoning with edge speeds. If they are right, and if they can scale this to multiple devices and use cases, they've potentially redrawn the map of where AI computation happens. This is where it gets complicated. If Xiaomi makes good on 1000 tokens per second at trillion parameters, some very big assumptions in the AI industry stop being safe. The first casualty is latency as a moat. Companies like OpenAI and Google have built cloud AI services around the idea that they own the infrastructure and can charge per API call. But if a model this capable runs locally on your device, why upload your data to the cloud? Privacy becomes a differentiator. Suddenly, processing medical records, financial data, or confidential documents locally isn't just nice, it's the obvious choice. That threatens subscription and usage-based pricing models. Second, device makers get smarter. If Xiaomi's built custom silicon for MiMo, that silicon is valuable. They control a huge part of the user experience. Samsung, Apple, and other manufacturers will race to build equivalent accelerators for their own models. The battle for AI changes from software to hardware. Third, edge deployment becomes the standard. Right now, most AI inference happens in cloud data centers because that's where the compute was economical. With trillion-parameter models running efficiently on devices, the economics flip. You can do inference cheaper on the edge. No cloud infrastructure, no bandwidth costs, no latency. That reshapes how software companies architect their stacks. Fourth, smaller companies get a shot. If you can license or run MiMo locally, you don't need to negotiate with OpenAI or build your own multi-billion-dollar GPU cluster. that democratizes AI deployment in ways we haven't seen. But here's the twist nobody expected. This also means data center operators and cloud AI providers have to innovate faster or risk commoditization. But here's what the headlines aren't telling you. You don't need to own a Xiaomi phone to feel this change, but you'll start noticing it soon. First, watch for Xiaomi devices launching with MiMo-v2.5-Pro built in. Those devices will have visibly snappier AI features. Translation, transcription, typing assistance, all faster. Other device makers will follow with equivalent models. Second, if you develop software that uses AI, this is your signal to start planning for on-device inference. Your API costs will drop dramatically if you change from cloud to edge. Third, watch enterprise software. Companies like Salesforce and SAP will start embedding local AI into their products. The software you use at work might suddenly become smarter and faster without the company paying cloud inference fees. Fourth, pay attention to AI privacy announcements. If a company suddenly says, "Your data never leaves your device," that's them deploying edge models like MiMo. That's a trust signal. Fifth, keep an eye on custom chip announcements from other manufacturers. Apple's probably already designing an equivalent accelerator. Intel, Qualcomm, and NVIDIA will announce edge-optimized chips. This race just went mainstream. The practical thing you should do is test any local AI tool that claims to use next-generation models. Try real-time translation on your phone. Try local code completion. Feel the difference between cloud latency and edge speed. You're experiencing a change in how AI infrastructure actually works. And this is where the real story starts. Here's what this moment means. Speed in AI just became a feature, not a footnote. For years, AI companies focused on capability. How smart is the model? How accurate? How knowledgeable? Speed was secondary. You'd wait for the cloud to respond because the response was worth it. MiMo-v2.5-Pro Ultra Speed flips that. It says you can have both. Billion parameter reasoning with millisecond response times. That changes everything downstream. It means AI moves from being a back-end service to being a core part of device experience. It means privacy and speed stop being trade-offs. It means smaller companies can compete with data center giants. The trillion parameter models that were exclusive to the cloud are coming to your pocket. Watch the next 6 months. Every major smartphone manufacturer will claim their own speed record. Cloud AI companies will scramble to explain why you still need them. New applications will launch that weren't possible when inference took seconds. And the baseline expectation for AI responsiveness will change forever. If you're interested in staying ahead of these changes, follow for daily AI news. We track the announcements that matter, the numbers that move markets, and the moments when AI stops being science fiction and becomes infrastructure. The race for the next generation of AI happens in speed and efficiency. And Xiaomi just fired a shot that echoes across the entire industry.